Hello, assalamu alaikum everyone. Welcome to today's lecture on fluid mechanics. Today I'll not be giving you any particular lecture. However, I'll be giving you the syllabus we covered so far in our fundamentals of fluid mechanics. So this is not a review class. This is a syllabus. I'll be mentioning you which topic is to study, which not to study, this sort of things. So basically, in this semester, we studied three basic topics. One is properties of fluid, fluid static, fluid dynamics. Fluid properties of fluid is like very basic of to understand the different phenomenon in fluid mechanics. And in fluid static is like we studied that for 2 months. And fluid dynamics, which is really important for this particular exam, and we focused on the fluid kinematics mostly. So some important topics, these topics are basically for the properties of fluid. These are the overviews, what we studied, and it's not an overview of what you studied, we studied more than that, but it's a syllabus I reduced so that you can do your preparation properly in the exam. So definitions of fluids and solids, like what fluid is, what solid is, what are the differences. In the class test, what you did was really bad, and because some of you wrote very mediocre writing, which is not acceptable with our standard, right? So you need to at least basically understand what fluid and solid is, and then we need to know three important topics, which is absolute pressure, gauge pressure, and vacuum pressure, and so on and so forth. This is not only important for the exam, but it is also important for the future classes we're going to have. In that time you may need to know the differences between these terms, right? The other kind of pressures, for example, static pressure and stagnation pressure, dynamic pressure. This kind of differentiation of different pressure is really important for all of us. Then what density is, basically it is rho, which is equal to m. In fluid mechanics we use this rho to quantify the mass in a unit volume. So this topic is also sort of important for us, at least for to understand fluid mechanics. And then you need to know the specific weight, specific gravity, specific volume. For example, we have a particular math problem. The rho is given and some values are given. So you need to know the specific, you need to find out the specific volume, specific gravity, and specific weight. So these three topic and the definitions are very important to solve any mathematical problem in properties of fluid. Also in the future problems, like if the specific gravity is given, for example, S is something 0.8, that means your rho is not given, your gamma is not given here. So you need to know how to derive those values using this S. So these are the fundamental topics you need to develop for the exam. Viscosity, kinematic viscosity, these are also very important. Is also a fundamental topic for fluid mechanics. And then we have very important topic, which is no slip condition. I think all of us in the class, I asked individually what no slip condition is. You have to describe them. If it's a larger problem, then you have to draw those velocity profile, like how no slip condition is affecting the velocity of the fluid. Then Newtonian fluid, non-Newtonian fluid, these are very important topic. Then viscid, inviscid, ideal fluid, what are their conditions, why we call them viscid flow, inviscid flow. This kind of stuff are really important for the exam, because in most of the cases the fluid mechanics exam is all about mathematical problem. But for our case, we also focused on mathematics, but we also need to know these conditions. Without these conditions, cannot become a good aerospace engineer. Well, you have to know these particular problems, particular conditions. What makes a fluid viscid? What makes a fluid inviscid? What are the conditions? These are the most important thing. You need to grasp this knowledge before you appear in the exam. Then bulk modulus. This is also a very important topic. You know bulk modulus and there its formula. You just need to plug them for mathematical problems, or you need to discuss what bulk modulus is in terms of compressibility or non-compressibility, like that. And another important topic is surface tension. We have avoided them in the class tests and midterms, but this is a very important and very crucial topic for our final exam. So here we studied like three different cases. For example, I'll mention two of them. Soap bubble, for example, or a jet flow, right? So what's going to happen there? Like what the delta P is, how to derive the delta P, right? You need to know how to derive them. Then I think you can solve the mathematical problem in the exam. Another very important topic is the flow through three plates, right? For example, we have three plates here. Here we have two different fluid, and each plate has three different velocity. Maybe this one is stagnant, that means the velocity is zero here. Maybe this one is stagnant. I'll not tell you which one came in the exam, but you'll find this kind of problem in the exam for sure. And for mathematics, for this particular chapter, you need to follow the PDF I showed you before. I sent you in the WhatsApp group, and then follow the class notes. This is really important. If you do not follow the class note, you're gonna get zero. I'm just kidding. You just need to prepare accordingly, right? In the fluid static, I think we spent around over 2 months here, right? And we studied different phenomena, like what happens in fluid statics. For example, we took a cube shaped fluid element, we took wedge shape element, and we derived different formulas and prove and so on and so forth. So what we did, like initially we proved that the pressure is scalar quantity. We took a cubic element and we derived an equation, and from that we reduced them into a point, and then we saw that all these vectors, pressure gradients, all the same from throughout different directions, right? So this is a very good practice. And then we have this pressure changes with height. That means if you go inside a pond, you will see the pressure is higher in the bottom than the top, but in the same height the pressure does not change. So this is a proof. I think it appeared in the midterm exam, and it is also very important for our final exam. Pressure distribution equations at different altitude. That means we have this different kind of equations like P rho g h. This is where the rho is constant, right? So if rho is not constant, what is going to happen? Those conditions you need to know, and the equations you need to know. The temperature varies. What will be that? What will happen to the P? If it's an ideal gas, what will happen to P? This kind of stuff I think you need to know before you appear in the exam. Manometer and similar concepts, these are really important for you guys, because I did not give them in the cities and midterms, and it did not appear anywhere in our exams, previous exams, but that's why very important for the final exam. What is a similar concept? For example, if you have a funnel, right, instead of a manometer tube, but they follow the same concept, so you can practice that for the exam. Force and center pressure of a submerged body. For example, if we have a water like that and we have a submerged body like this, and we need to find the center of pressure, that means where there we need to find the equivalent force and where the position of that equivalent force. We need to find those two, right? It can be a arbitrary body, it can be an inclined body, a vertical body, or curved surface, anything. These three conditions, anything can appear in the exam, but this will be in the exam for sure. Then pressure prism, trapezoidal pressure prism concept, these two are also very important. You can look into my video I posted on YouTube, and you can get the concept from there, and I think the description is very clear in that particular video. For math, I think you can follow the Robert Mott, his applied fluid mechanics. I sent a PDF to you guys in the classroom, and you can also find it in the library as well. So you can grab one of those books and you can practice one or two big problems from the book, because if you follow one big problem, it will cover everything. So I'm telling you, like, do not try to practice everything. Just practice the biggest and hardest problem in the book. Eventually other problems will be very easier for you guys to solve. Follow the class notes for the maths, gave you at least 4 to 5 mathematical problem using this curved body problem or inclined body problem and so on and so forth. And I made a video about the pressure prism concept, so you can look into that as well. Submerged body problem, yes, that's the same thing, are very important. These are very important. Okay, then fluid dynamics. This is the most important and hardest topic we studied in our throughout the fluid mechanics. So in that case, you need to be very careful. You need to be very careful while studying fluid dynamics. Even though these memories are very fresh because we finished this topic very recently, and most of the problems, like if you have 8 problems in the exam, 3 of them came from the previous topics we discussed, and 5 of them are from the fluid dynamics. You need to know the derivation of Bernoulli's equation. Every part of the Bernoulli's equation is important because how to derive them, the mathematical problem. Because Bernoulli's equation is very, it's kind of a governing equation for any kind of incompressible flow field, right? So this is not only important for you guys in the exam, but also for your real life in fluid mechanics. Then streamline, path line, these things are really important for you guys. You need to know the difference, like what path line is, what streamline is. And this is a stream equation. This is also very important. You need to solve 1 or 2 maths of a stream equation. You can practice from the book, Monson's book. You can also look into the retake exam. I gave some sample problems there as well. Then you need to know some conditions, like these conditions are very important. This one should be steady flow, not steam flow, steady flow. And then you need to know what uniform flow is, unsteady flow, compressible flow, incompressible flow, viscid flow, inviscid flow. So these are the conditions you need to know, like what they do and how they affect the fluid, how they affect their flow field, so on and so forth. The question may appear like this: write down the conditions for compressible unsteady flow. So for compressible, I think this one is not constant, and for unsteady, the d by dt is not equal to 0. So r is a random value. Okay, it can be velocity, it can be density or anything like that. So this is really important, like you need to know these conditions, and they are very important for the exam. Some combined problems using Bernoulli's equation and continuity equation. For example, you have a pipe and there's a flow through the pipe, and there is sudden change in the diameter, right? We solve this problem in the class. So these are the combined problems, like there is a fluid flowing in this direction and going out. So you need to utilize the continuity equation, also the Bernoulli's equation to solve this problem. So for Bernoulli's equation, you can follow Munson's book and the class notes. In the class note, I gave you lots of problem from the internet. For example, the wind tunnel problem. I gave you some problems with different variable pipe diameter, and I showed you some phenomena, what happens with the aircraft wing. Everything you need to follow my class notes. I think you'll be able to solve. I think this is the easiest problem you'll face in the fluid mechanics exam. Now here comes the hard bit. So here you need to know the acceleration field, what acceleration fields are: ax, ay, az. For example, if we have a acceleration, you need to know the ax, ay, and az component of acceleration. Then you need to know how to material derivative this one, also this one, and that one. This is really important for you guys. There are some terms. For example, for material derivative, there is a local term and there is a convective term. Those things you need to understand, and you can follow the retake exam for to take it as a guideline for you guys. Also, you can take my class notes as your guideline. Then streamline coordinate, this is from the Bernoulli's equation. For example, in Bernoulli's equation, when we have a streamline, it's going like this, we do not take the Cartesian coordinate system in general, like for example this x and this is z. So we do not take the Cartesian coordinate system as our coordinate system. We take a natural coordinate, which is streamlined coordinate. The direction of the velocity is s. We take it as a one coordinate, and then we take the normal direction, which is n. For 3D case, we also have a y coordinate. This y and that y is the same. Different forms of Bernoulli's equation. This is really really important because there are lots of Bernoulli's form. For example, head form, we have the pressure form, we have energy form, we have different forms of the Bernoulli's equation. So we need to know every kind of Bernoulli's equations form, like how to derive them. And then we need to know the stagnation pressure. Stagnation pressure is really really important. Like you can have a mathematical problem from there, you can have proof that stagnation pressure is larger than the static pressure. Reynolds transport theorem, these topics are 100% important. These topics are 100% important. Why is that? Because they're very difficult. And the purpose of the exam is to solve critical problems, right? So you need to be able to derive Reynolds transport theorem, and using Reynolds transport theorem you need to be able to derive equation for conservation of mass, and also you need to be able to find the energy equation. Furthermore, you need to know the extensive property, intensive property, what are these, describe them. Then you need to know different types of losses in a system. For example, we can have different kind of gain, and you can have different type of losses, head loss, and so on and so forth. And do not try to memorize anything for the exam. For example, just remember how to steps, how to solve particular problem, right? And different assumptions and conditions are required for specific problems. You need to remember those. Do not memorize, just remember. Derivations are important, maths are equally important, and for the maths, follow the guidelines I have provided in the previous slides. Thank you very much. I hope you will be doing very great in the exam, and all the best. Thank you.